pressure looks good.
Traveling up. Roger, Atlantis.
Water towers can fly! Yes!
Tango Delta nominal.
Flighting outside SC off. Bring in SC off.
Yikes. You bet. Okay. We don't need any more of these.
Hello, everybody, and welcome to NASASpaceflight Live. It's time for the weekly news show, and I don't know. I don't think anything happened this week. There's not much to talk about. I'm kidding. There's so much to talk about. I don't know how we're going to fit this in 90 minutes, but we'll do our best. My name is Thomas Burghardt, news director for NASA Spaceflight. Let me know in chat if you've got us 5x5. I'm going to steal Das's jokes, and they're already coming in. We're good. Thank you so much. Glad you all can tune in with us. I've got two of my good friends with me to discuss all things space. On this side, we got Haygen Warren joining NASA Spaceflight Live. Haygen, how you doing today?
I'm good. For those who know what I do at NSF, I think you know what we're going to talk about today. So, yeah, I'm super excited to talk about a certain telescope that did something really cool, whose images were released this week. So, super excited to be here.
Yeah, Haygen Warren is one of our senior science writers here at NASA Spaceflight, and his specialty is, of course, things like the James Webb Space Telescope, which may or may not be relevant this week. We'll get to that in a second. On the other side, we got Mr. Chris Gebhardt, assistant managing editor of NASA Spaceflight, and Chris and I got the memo with the James Webb merch going on, so we've got James Webb stuff everywhere. But Chris, how are you doing?
I am doing just fine, and I must compliment Haygen on like the two models he has chosen, because he's got Shuttle for me and Ares 1X for you. I mean, he really pays attention to like his audience here.
We got Ares 1 in my background too. This is my. I haven't been in NSF Live from this place yet, so the background is a work in progress. But we got Ares 1 represented, and 2 of 3, which I'll take. I like it. Everyone, as you all know, if you're new here, you may not know. So for those who may be new, please tag us at NASA Spaceflight if you have any questions throughout the course of the show. We're going to talk about a whole bunch of different things. Of course, we're going to deep dive into the James Webb Space Telescope, the first images and science being released from that mission. We're going to deep dive into all of that. Also got some news regarding Roscosmos and the Russian Space Agency, a little bit from Virgin Galactic on some new spacecraft they're working on. We'll recap the launches from the past week, and we are, of course, going to also deep dive into the latest from Starbase Texas and the Starship program, especially Booster 7's adventures this past week. But we're going to go ahead and start off with the James Webb Space Telescope. So, Chris, let's start with you. How do you want to even start this? There's a bunch of different images. There's a bunch of new science that has come out. So I'm going to hand it to Chris and Haygen, the science experts, and let's deep dive into some of the first results from the new space telescope.
So I'm going to start with when the images first came out. It was stunned silence. It was honestly stunned silence, because looking at especially the first deep field image that was the first of the 5 that came out. I mean, when you can see the gravitational lensing that's taken place in these photographs, and like just understanding that what you're seeing you shouldn't be able to see because it's technically behind the brighter object, and that this is an image that proves part of the theory of relativity. I mean, just the image proves it, not the science behind it. Just the image proves it. But I think I felt what a lot of people did. It was like, I saw them and I had it, and they're so good. They're so amazing, but we're so spoiled with computer generated images in science fiction now that until they actually did the comparison and said, well, but now look at what Hubble could do. And then they put them side by side, and then you really see like, oh my gosh, how much more can Webb see? How much clearer can it see? And I mean, this isn't even the best one of the 5 photos we have so far to even talk about that. But I think that's when it really started to connect in a way that made sense to me of what it is that we were seeing when you could do that comparison between this is what we all got used to with Hubble, and we're literally able to count the grains of dust in a nebula now. And Haygen, I don't know about you, but like the one of the Carina Nebula and the star formation region, the stellar nursery that's inside of it, it was actually the zoomed out photo, when you got to see how zoomed in that photo was to the Carina Nebula in reality, when like if you're holding up, like if you hold up your hand, right, and the entirety of your hand is the nebula, you're looking at like a small little cluster of skin cells on your thumb, and it's that detailed. I mean, it's mind blowing, and that's before we even get to the science behind it. That was my first reaction. Haygen?
Yeah. Oh, I think Thomas saw a little bit of my first reaction, but I couldn't believe it. I still don't believe that the images are actually out. I've only been covering James Webb for about a year. You, Chris, have been covering it for a while now, and even though I haven't even, I mean, obviously I've known about Webb for a while, but being able to talk to the scientists and stuff behind it throughout the past year leading up to its launch, and even after its launch through commissioning, it's so cool to see all the work they put into it and to finally know that they know that it worked. We have these amazing, stunning, glorious images from this telescope, and these images, what's even crazier to me is that these images are basically sort of like the bare minimum of what Webb can do, and they are insane. Especially the deep field image. Going back to that, it took Webb 12 and a half hours to take that entire image, which is insane whenever you consider that it took Hubble with its 1995 deep field image 10 days to capture that image. And so imagine what Webb could do if it took 10 days to capture a deep field of SMAX 0723, which is the target of the first deep field. Yeah, just thinking about things like that just blows my mind. With the exoplanet with WASP 96b spectral data. Yeah. Definitely. Yeah, there'd just be galaxies everywhere. But going on into what else was released besides, we briefly mentioned the Carina Nebula image of NGC 3324. We have SMAX there. The next image that was released after the first deep field was spectral data that Webb took using its NIRIS and NIRSpec instruments of WASP 96b, which is an exoplanet around WASP 96, which is the G-class star. I'm forgetting how far away it is. But basically, up until the Webb data was collected, we sort of thought that there weren't any clouds on WASP 96b. But to the surprise of, I think, everybody who knows about WASP 96b and who works on Webb, they found clouds, haze, and a water signature in the atmosphere of WASP 96b, which is so cool, especially for me. I love exoplanets. So seeing this and getting this data and having the light curve and having the transmission spectrum is so cool. So it looks like we're having issues pulling up.
I might have sent Michael a bad asset. Oh no, that didn't work. Hold on, I'll find it, Michael. I got you.
But Haygen, what you were just saying, especially if you compare the sort of the deep field that Webb was able to produce and the spectra data that you were talking about there with WASP 96b, right? It was a shock to find the clouds around on that exoplanet because the theoretical models to date said there shouldn't be any there. So like already Webb is telling us we know nothing. I mean, like that the universe is a wacky place, and just because we don't see something here in our solar system doesn't mean it can't happen elsewhere. But the other thing about the deep field that I thought was so incredible, and we'll come back to this light curve in literally 2 seconds. But it is that in that deep field, it was able to pull out the spectra of individual stars as well in those galaxies, which was truly amazing. Because it's finding this spectra data on individual stars in these galaxies that are billions upon billions of light years away. And we'll get to how the galaxies can be further away than the age of the universe in a minute. Because I'm sure that's a question. That was definitely a question that came up a lot this week. But if it can do that with galaxies that are billions and billions of light years away, now look at what it can do with this light curve data from WASP 96b, which is essentially in our backyard, right? And pulling out that water vapor data, pulling out that data that's showing that there are clouds within its atmosphere. I mean, this was one of the central and crucial things that Webb was going to be able to do, which was to unlock those secrets of the exoplanets as they transit between its point of view and their parent star. And I mean, this data again was based on what was it? It was like 2 or 3 transits of the exoplanet. It wasn't that many that sort of pulled
Yes.
all this out.
I believe
and
it took. Yeah. Yeah. It took it about 6.5 hours or so. That's how long it observed. WASP 96, looking for those transits. So I need to go back and look at how far away 96b is from the star, but yeah, that sounds about right. Like 2 or 3 orbits or so. Yeah, so observed for about 6.5 hours and was able to pull all of that out, which is insane.
Well, if we look
Yeah.
at this actual graph, you can look the x-axis near the bottom. Well, I guess it's not an x-axis. The horizontal axis starts a little bit after midnight and ends a little bit after 6 a.m.
Yeah.
So if it's a 6-hour-ish observation, that graph indicates that's only one transit, doesn't it?
It does, yeah. So this would be the readings that they got from a singular
yeah.
transit, and then,
Right, okay.
Yeah.
of course, the reason you want to do more than one is to confirm that data, because you want to make sure that there wasn't something weird that just happened to be between the vantage points and lined up perfectly, which can happen sometimes, right? Where you think you're looking at something inside of of one system, but what you're actually seeing is something that's a little bit behind or a little bit in front of the system from our viewing angle. But I mean, the fact that we were seeing that in this light curve data is just mind blowing when you think that the big system that it is now set to look at during observational period number 1 is the TRAPPIST-1 solar system, which has 7 confirmed exoplanets in it, all in myriad, all spread out, around this red dwarf. It's going to be absolutely fascinating to get that spectral data on what those planets are comprised of, and really start to dig down into this idea of habitability, and specifically those planets that are inside the habitable zones of these other stars. And if you are suddenly pulling out water vapor spectra from a planet that is within the potential habitable zone of its star, really got something there now all of a sudden.
Yeah. Yeah.
All right, so
Oh,
let's see. We talked about the
okay.
deep field. We talked
I
about
guess we
WASP
can move on.
96. Yeah, what other images haven't we touched on? I don't think we talked about the Ring Nebula yet.
No, we haven't talked about the Southern Ring Nebula. Okay, so this was the first, I feel, truly mind-blowing image we got from Webb. It was the third release after the Deep Field and WASP 96b's data. And you can just look at it. What else can you do? I mean, it's it's insane to look at that. And thankfully, the team imaged the Southern Ring Nebula, with both the near infrared instrument and the mid infrared instrument. So this image right now that you're seeing is of the Southern Ring Nebula in the near infrared. As you can see, there's those central stars in the middle of the nebula there, and those are what shape the overall, I guess, shape of the nebula. So if you look closely in the nebula, actually, and I wanted to point this out because it's really, really, really cool that we're able to see this. You can sort of see these brownish lines inside the nebula. Those are sort of like shells that are released every single time the two stars in the middle, that bright light you see, that star that looks like a singular star is actually 2. Every single time they orbit one another, the dimmer star, which actually caused this nebula to happen, it releases a bit of its mass. And so it releases these lines right here, these shells is actually mass and material from that star. And so basically, the closer the shells are to the central stars there, the younger they are. But whenever you back out from the image and look at the brownish, reddish parts of the nebula, those are all shells and mass from that star whenever the nebula first formed, which is so cool to think about, that we're able to see that. Yeah, Chris, any thoughts?
Oh,
mean,
I mean, several.
I mean-
The fact that Webb is sensitive enough in the light profiles that it's able to discern that we can clearly make out the two stars, right? And there was another sort of image from this that did clearly show both of them as well, and you could see the sort of dimmer one that was there. And I mean, what's cool is that, you know, these are companion stars, and one is undergoing this sort of rapid evolution. The other hasn't really started this yet, but will eventually do that. So like, if you think of this nebula on its, you know, on its large blah 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 larger cosmic timescale, that's the one where you can see both, right? By just switching images within, or by switching instruments on Webb, you can see the redder, fainter one and the brighter, whiter one there. But what you're seeing, right, is just one star producing this. So when you think of the nebula and its cosmic timescale that's going to continue, right, eventually this other star is going to start doing this too, and going to start shedding its mass, and this nebula will continue to grow. But it leaves behind this potential star forming region later on in its existence, and also gives this wonderful little time capsule, like the rings of a tree, to be able to see how this death of a stellar pair is unfolding. And when you one thing that I couldn't help but look at this and think is, you know, when our own solar system continues to evolve and the sun goes through its, you know, end of life routine, is we're going to be a nebula at one point, just like we formed from. And it's kind of cool looking out at this, looking at how stars shed their material and what that actually looks like. Because I think from Hubble, right, you get this idea that it's a very sort of uniform, it's a very uniform cloud, right? Like when you look up into the sky, right? But it's not. It's more like diffusing something in water, and it all clumps together and is still being shaped by stellar wind and like water currents, and it's more akin to that. And I think that's one of these images that Webb really revealed in this case is what this stuff actually looks like, and what a potential better way of thinking about it and thinking about what nebulae actually look like is.
So cool, so cool. All right, let's go into Stephen, whatever pronunciation of that name we want to use here. The quintet of four
Stefan's quintet,
different
Stefan.
Stefan's quintet. See, Haygen would know. All right, this is my
Five
personal
galaxies.
favorite. Yeah, five. Sorry, five. Yes, numbers are hard. This is my personal favorite image. Tell us all about it, please.
This is mine too. This is my favorite. So similar, just like the last one, just like the Southern Ring Nebula. Just look at it. So let's just overall go over what Stefan's quintet is real quick. So it's a group of 5 galaxies here. But what's interesting is that only 4 of these 5 galaxies that you see are actually compact and close together. The far leftmost galaxy there, which is I believe NGC 7320, is actually much farther away from the other 4 that you see on the right side. So it's kind of interesting. The 4 on the right side are about 270 million light years away, and the leftmost one is only about 40 million light years away from Earth. But because it decides to photobomb the other 4, you know, we just include it in the quintet.
What we were talking about earlier.
But let's just talk about. So let's just look at what we're seeing here. So the most eye-catching part of this image to me is sort of the middle 2 galaxies on the right side there that are colliding. And I believe that reddish area above them are stars interacting, which is so cool to see. And another cool thing that scientists noted with this image is that the topmost galaxy has an active galactic center. And inside of that galactic center, there is a supermassive black hole that is actively consuming material. And I'm not sure if I put in the asset for this into the link stock, but they actually imaged using some IFUs on MIRI and NIRCam, and were able to see the gas and dust shooting out away from that black hole, and were able to measure the velocity of that material. which is really, really, really cool. I guess something else that also just boggles my mind with this image is if you look behind the actual 4 galaxies there's just more galaxies. And it's such a beautiful landscape just to look at there. It's just galaxies, with the exception of like maybe 5 stars or so. Yeah, look at that. It's just all galaxies. And it's
incredible.
amazing. Yeah. Chris, take it away with your thoughts.
Yeah. I mean, it's not just the fact that these are galaxies that are interacting with each other. It's galaxies that that are in the process of combining with one another, right? And what that sort of leads to, right, in terms of the overall energy that is imparted into the system, the new realms of star creation that can take place inside of galaxies that maybe that's dwindling, right? Because one of the things that we look out when we see these other galaxies is we see some that are, in wonderful periods and bursts of stellar creativity, and by that I mean stellar births, right? New star creation and new star formation. And then you see others that are sort of dwindling and not doing as well as everything continues to expand, right? And these collisions between galaxies can sort of kickstart that new evolution series of stars. And of course, the more materials that are there to form stars, the more different types of stars that are, there are that form, the different types of materials that they create are formed. Everything sort of started as hydrogen, and the larger elements that we have now are because of the deaths of previous stars earlier on in our universe. So it's just all part of that wonder and insight into how this happens. But I think the thing that really struck me about this one and the and its connection to the deep field image that we showed earlier is that these are the images that sort of really show us, okay, is galactic development and evolution and stellar development and evolution constant throughout the universe? And this is one thing that Webb can sort of help us understand, right? Is the process of forming a star and forming a galaxy and the way that they evolve after that initial formation, is there just a set way that this happens, right? Barring, interactions, or even with these interactions that take place. Is that something that has not really changed over the evolution and lifetime of the universe? And if the answer is no, that tells us something, right, about how very consistent these things are. And if they're not, that opens up a whole new sort of puzzle box of why has it changed and how has it changed and what does that mean? And that's sort of one of those underlying questions that these images can really help us understand.
Awesome. All right, we've got a whole bunch of questions coming in about all the different images and stuff we talked about. So let's dive into some Q&A about James Webb stuff. And our first question is from Musical Wolves, who ask, some of these questions are about comparing to other telescopes. How would Hubble do at the L2 point compared to James Webb? Because obviously the two telescopes have different technologies, and James Webb is newer, but they're also operating from different points in space. Hubble is a low Earth orbit telescope. James Webb is out at the L2 point. How does that affect the performance of the two telescopes in comparison?
Probably not as much as would be envisioned. Hubble is still up above most of the discernible atmosphere, so it's not really the atmosphere of Earth is not really a contender for either of them in that regard. What is a bit more interesting is that there would be things that Hubble would be trying to aim at because it's in orbit of Earth, and specifically at a 28.5 degree inclination, that there are some things that it can only observe when it's on one side of the planet. Right? Obviously, things to the north and to the south, it can sort of re-aim itself and do a sort of constant observation depending on where the sun is, because you can't really aim Hubble toward the sun. You can't aim Webb at the sun either. But that's more of the weirdness of utilizing Hubble. Is more the things that being in orbit of Earth prevent, and how things like the South Atlantic anomaly affect telescopic observations like that, whereas Webb doesn't have to contend with that. It can sort of aim itself at one location. It doesn't have to worry about where Earth is as it's orbiting. So in that regard, it's not a issue. And I say all of that because my actual answer to this is Hubble would have outright failed in L2 because it was nearsighted. and we never would have been able to get to it to repair
Oh,
it.
that's true. That's a very good point. That's
Yeah.
true. Huh. Well, there you go. All right, let's take some more questions. Khalid asked, when is the next image release? I believe these were the first ones, but haven't we already started to get like 2 more or something? Like I saw one of Jupiter that was
Yeah,
going around. Let me see if I can find that quick.
Answering the question for a lot of people of what can it look at in our own solar system? Jupiter and beyond is basically the answer to that.
Yep.
Yeah, all right,
Yeah.
Michael can Google it
Well,
faster than I
actually,
can.
this
Thank
is
you,
actually
Michael.
this is actually kind of interesting. If I'm remembering correctly, this is an image that Webb took of Jupiter during commissioning.
Mhm.
And Thursday, I believe, teams from NASA and ESA and CSA basically released all the commissioning data, a very good large portion of commissioning data, which included a lot of images that Webb took whenever it was first testing out MIRI and NearSpec and NearCam and all of its instruments. But definitely now that it's an operational telescope, we're going to be seeing, which first off, it's crazy to say that Webb is an operational telescope, but we're likely going to be seeing a lot more images come out, especially in the next few weeks as first science results come in from the first observational cycle that it does. We've already seen a few new images floating around on Twitter from scientists whose research is actually already being used on Webb. So it's definitely be on the lookout on like NASA and ESA sites for whenever they post articles or something. I have not yet seen a sort of data archive for images, but whenever we do, I'm sure I'll be posting it all over the place saying, go look at this image, this is so cool. But yeah, as you can see right there, Michael just put up some awesome infrared pictures of Jupiter. And I believe in one of the images we could actually see Jupiter's rings,
Yes.
which was really, really, really cool.
In the second one here, you can see it
so-
actually.
Yeah. Yeah. There we go.
Yeah, in the
Ah,
more
so
purpley image, you can see the rings very clearly. Yeah.
Fun fact, Jupiter has rings. Not everyone knows that because they're very faint compared to, Saturn, for example. But they're there. That's cool.
And for the longest time, we didn't know they were
There
there.
you go.
Right.
There they are.
All right, let's
Yeah.
see. So basically more images coming on the way. I'm just going to plug Haygen's Twitter real quick. If you don't follow Haygen on Twitter, that's honestly the best way to keep up with science results from space missions because he's tweeting about them all the time. Not just James Webb, but he's tweeting about the Mars surface missions and things like that. So follow Haygen on Twitter. That's the best. There you go. At Haygen Warren. It's a very easy handle to remember.
You'll occasionally get maybe like a keyboard smash from me whenever something like ludicrously cool like is released.
That's true, actually.
I saw something the other day of a 12-year time lapse that Keck took of a star, and it shows these 4 exoplanets orbiting around this star, and I thought I was going to lose my mind. That was so cool. So
Yeah, like
there'll be
not
occasional keyboard smashes every now and then.
Yeah, like you said, like it's not just, and this is what excites me about Webb, right? Like it's not just that we can detect these exoplanets around other stars. Like we're starting to be able to image them directly now and like watch their orbital progressions, and that's really cool. Yeah.
All right.
It's gonna be so cool. That's gonna be so cool.
That's how you stay up to date on the latest James Webb images to answer the question. But yeah, we got a couple more questions here. What causes those horizontal diffraction spikes? I believe that's probably the easiest example for that is probably the deep field image, but it comes up in a couple of them.
Oh.
Anyone want to explain the optics behind that quick?
Go for it, Hagen.
Well, I can try. Light and diffraction is not my best subject of physics, but if you look at the deep field image, right up front and center, towards the center of the image, is this super bright star. And if you notice, there are these 6 spikes coming off of the star, and those are called diffraction spikes. And you'll notice that there's 6 of those for these 6 sides of Webb's mirror. And it's interesting that we're always going to be able to tell the difference between a Hubble and a Webb image.
Oh, that's true.
Hubble images, the stars have 4 diffraction spikes, and Webb's images have 6 diffraction spikes. So diffraction spikes occur, if I'm remembering correctly, Chris, you can back me up on this, occur whenever the light sort of follows the mirror's shape. I'm kind of blanking here. But yeah, there you go. Michael circled it.
Yeah, it's basically a combination of the wavelength and the horizontal pattern of the lenses, and how everything is hitting the lenses and bouncing through the optics of the telescope to get you those things. So yeah, whenever you see the star burst, or if you're watching a J.J. Abrams movie, there's a lens flare. There you go. Like,
Yeah, but you can see like all of the like brightest points in the image have the exact same diffraction pattern because it's all obviously all bouncing off the same mirrors. But you can kind of tell how. You can also tell if they ever like edit a picture and rotate it in any way, you'll be able to tell because the diffractions won't be vertical anymore. So if NASA tries to pull a trick and like rotates an image for whatever reason, you'll know. There you go. Chris has got the model in front of him.
Right, and
There you go,
so you
Chris got it,
so you can see, right, like each individual mirror is actually the shape of the overall larger mirror that is constructed from each of the 18 individual mirror segments that Webb has. And you can see that's following the exact shape that Michael drew, right, from the starburst that you can see there. So yeah.
Someone in the chat says, "Do you think they'll ever take a picture of the third planet from the sun?"
Which sun?
Chris with the good answer. Good answer.
Oh yeah.
Although I appreciate the throwback to the TV series though there too. Like,
All right, I got a couple more questions here. Hold on, I'm going to do that one last. First one, could we expect any sort of improved cosmic background radiation image or research from the James Webb Telescope?
give me a second.
Uh-oh, Chris is furiously Googling. Really quick, I'll thank Jay French for becoming a Capcom member. Thank you so much. Corporal Daywalker, gift 5 red team memberships. Multispace Industries says Science Besties fan club, so thank you, Multispace. Appreciate that. Dan with the red team membership, and then Kevin upgraded to Capcom. So thank you all so much for your support.
So, I mean, the cosmic microwave background radiation
It's the wrong wavelength.
Is really radio astronomy more than what Webb can see. What I was trying to find really quick is what those actual wavelengths were in comparison to sort of show you. But it's not close to Webb's overall capability. So no, in that regard. But I've got. Let me find the wavelengths, and we'll come back so we can see exactly how far away those actually are from one another.
Okay, cool. All right, one last question on James Webb, and then we're gonna move on to some more news. But this is for Haygen and Chris. Which celestial objects would you most like James Webb to image in the future, and why? Chris, you get to go first.
Oh man, what do I really want them to image, and why? Well, there are a lot of reasons why it's not going to realistically be a target because of basically how its orbit is and radial methods of detection versus transit. But man, if there were a way for it to actually look at Proxima Centauri B, the closest exoplanet to our solar system, I would really love that because that is one that is literally like our neighbor. And there are some interesting ideas of how we could do a mission to Proxima Centauri or Alpha Centauri here with slingshots and lasers being fired at solar sails to accelerate things to, something, a speed that we could basically get something there in about 20 years or something like that. Really, really cool. But outside of that, the thing that I would really love for it to be able to do, but it requires finding it first, is I would love for it to be able to examine Planet 9 in our own solar system. And of course, this is predicated on Planet 9 actually being there and the mathematics bearing out, from what Constantine and Brown are sort of working on there with their teams. But, Webb isn't really a good tool for finding it. But once it's found, Webb is an excellent tool for figuring out what it is. and examining it, because one of the interesting questions that is going to be asked very quickly about Planet 9, if we can find it, is it native? Is it potentially something that when Neptune and Uranus did their weird thing and migrated out to where they currently are, was there another planet there that we didn't realize and it got flung out to this really large distance? Or did we grab it from another solar system as we passed it? Or was it a rogue? And Webb can really be able to answer that quite well. And here we go. We have an answer. So this is how far away the wavelengths are for cosmic background radiation, what Webb can see. So the peak wavelength of around 1 millimeter is for cosmic microwave background radiation, while the JWST is seeing between the 0.6 and 28.3 micron wavelength. So far
orders of magnitude off.
Orders
not
of,
even
yeah,
close.
Yeah, the measurement unit is different. Let's put it that way. Yes, but that's what I would really love for Webb to be able to look at here. What about you, Haygen?
Oh, that is a very, very, very difficult question to just answer. But I think I have a few. The first one for me is for it to image and probably collect spectral data on the PDS-70 system. For those who don't know what that system is, it's a new system. It's a young planetary system. I think it has 2 exoplanets. Yes. PDS-70b is currently accreting, and we were able to image it in the UV for the first time and collect data on it in the UV for the first time last year, which was really, really, really cool. But if I had to pick a single planet for it to image and collect data on, it would be PDS-70c, because last summer we found out for the first time that they had directly they were able to confirm that there is a moon-forming disk around PDS-70c, and we're able to image it. I would love to see what James Webb can do if it were to image that, just the overall system, what we would be able to see. And I would also love, 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 love for it to collect spectral data on these planets that are still forming, so that we can know what goes into a forming planet's atmosphere. That would be so super cool to see. I'm trying to think of what else. I have a whole list in my head. There are several galaxies that would just be awesome to image. But if I had to pick one thing, it'd probably be the PDS-70 system, because getting that type of spectral data in on what's going into a newly forming and super young exoplanet would be so cool.
And one thing that I just want to add to that, and why Webb might really work there, because as soon as you said the name of the system, I was like, yes, because the dust that's still in the system was a problem when they were seeing it in the UV spectrum, right? Like we could see it, and we could kind of see the moon forming, and we had an idea of what PDS-70b was doing as well, but that dust was a problem. And if you go back to those images of the Carina Nebula and compare them to what Webb was able to see versus what Hubble was able to see, right? Webb is able to see through some of that dust and reveal what is beyond that dust and within that dust, based on the wavelengths that it sees at. So yeah, oh my gosh, like it could probably do wonders for us in figuring out what is going on there with planetary formation. Yeah.
There you go. So, safe to say that we're going to have some continuing James Webb telescope coverage on NSF Live and other NSF coverage for the foreseeable future. Obviously, we're just getting started. If
We
you
might
would like
need a
to
new article tab.
Yeah, honestly, it's going to be a new category on the news site. But if you would like to show your support, not just for the James Webb mission, but also for NASA Spaceflight's coverage of the mission, you should check out the NASA Spaceflight store and check out the Time Machine merch, which is one of my favorite merch items. You can see I wore it today because it's relevant. But you can go to shop.nasaspaceflight.com and get your own James Webb merch. It's still up there. It's been up there since, of course, Chris traveled to French Guiana to see it launch. Crazy to think that wasn't even that long ago. But yeah, a great way to support NASA Spaceflight. And of course, if you're a fan of the mission and the new images, go ahead and get yourself a shirt. We thank you so much for all of your support.
Because Webb is a time machine, right? It is literally a time machine. I mean, this. I mean, I know this caused a lot of questions, but it really is true that it's seeing the light from these things, and the the oldest light in the spectra of that deep field image was 13.1 billion years old. And that's mind-boggling to begin with. But then you realize that the galaxy it came from is now farther than that away. It's like 30 to 40 billion light years away. And of course, people go, "Wait a minute, how can it be farther away than the galaxy is old?" That doesn't make sense because it took the light 13.1 billion years to get to us, right? We did not exist. The progenitor of what we came from did not even exist when this light was emitted. I mean, it's not just that the sun wasn't here, it's that the thing that caused the planetary nebula that the sun formed from wasn't even here yet when this light was emitted. And those galaxies have been moving because the universe is expanding, right? And that's how they're able to be farther away than they were when they were released. But I mean, it's just mind-boggling. I mean, 13.1 billion year old light is only 600 million years after the Big Bang. I mean, that is essentially the
Only
first
600
light.
million.
Only 600. I mean, it is essentially what they kept telling us: first light. Seeing back to the moment of first light, and it's almost right there in that image. Except they can probably get a little farther back with a longer exposure, which is just.
Mm-hmm.
Yeah. All right,
Yeah.
and Chat, what do you think I have to do to get Michael to change the background of this scene to the deep field image? Maybe we have to look into that. Because I was just looking at the scene and I was like, I wonder when the last time we updated this was.
Do that, Michael.
Anyway, that's the James Webb news for this week. I'm sure we're going to be talking about that a whole lot more going forward. But there is some other news from this week that we should also be talking about. And let's go ahead and move on to some updates from Roscosmos, the Russian space agency, of course. Two big updates that are actually mostly separate, even though everyone was like, well, that's a coincidence. It was actually a coincidence. The first things first is that Dmitry Rogozin, who we've talked about before, he was the director general of the space agency, their equivalent to their, like the NASA administrator, if you will. He has been removed from his position and is being replaced by a new man by the name of Yuri Borisov. And Borisov is... I mean, it's hard for us to have a whole lot of insight into this. Maybe Chris or Haygen, you guys can chime in if you know more than me about what the opinions of these people should be. Obviously, the insight into Russian politics is questionable from the United States, but he did give in his first press appearance as the new general director, was that his priority was really aiding the Russian space industry, so mass producing spacecraft components, really focusing on being able to the supply chain almost behind their industry.
Military.
And that includes he said both military and civilian spacecraft, but obviously that's going to include their military space, which has probably been the most active recently. They've been launching a lot of military satellites. That's not supposed to be a direct correlation to current events. Military launches get planned months and months and perhaps even years in advance, just like the United States doesn't all of a sudden have a bunch of new military satellites when these things happen. But that's kind of his priorities that he's laid out as the new director of Roscosmos. I'm going to lay out a question to Chris and Haygen here. From an international partner perspective, because obviously we are much more familiar with the NASA side of this relationship, what would we want to see from the leadership of Roscosmos, knowing that it is at least partly separate from the leadership of Russia as a whole? Chris, you want to lead us off?
Well, I think the biggest and important, the biggest and most important thing for me is that I don't expect a lot to change, right?
Sure.
I mean, Rogozin clearly fell out of favor with Putin, but Rogozin also oversaw a period of Roscosmos that a lot of us have sort of that has sort of gone by the wayside based on the other things that have come up, right? I mean, their safety initiatives were declining. They had losses of both the Soyuz 2.1A and 2.1B rockets. I mean, ironically, as soon as the shuttle program was retired in 2011, less than 2 weeks after the final flight, they lost to Progress in a launch failure. And everything like that. So there had been issues along the way. Rogozin was very blustery and public, and there were obviously a lot of things that got said that were never going to come to fruition, right? We're just going to go it alone. Well, they're not just going to go it alone, right? We're going to leave the International Space Station. Well, they're not going to leave the International Space. I mean, it was just a lot of blustering and performance that went nowhere. But at a certain point, when that performance goes nowhere and the Russian government figurehead, you've got a problem. So based on the issues that we had seen, throughout Rogozin's tenure, it's not a surprise that his replacement, for lack of a better word, I don't really think it's more so much successor in the Russian agency as it is you get replaced. But with our new head over Roscosmos, it wasn't a surprise to me to hear him say focus on supply chains, focus on getting those things, and not a focus on science or cooperation. That wasn't really a surprise to me given the current political climate and the issues Roscosmos has faced. And of course, they want a little bit more independence, but they've got this issue of the collapsing launch market because the Western world won't work with them anymore. So not an overall surprise, but I don't think a lot of us know a lot about him or enough about him to really say what's going to happen. So I don't expect a huge shift here, especially with the just announced crew swap agreement between NASA and Roscosmos, which we'll get to in a minute. Yeah.
Right. Yeah. Well, so let's dive into that too. Well, let's dive into that,
Yeah.
and Haygen, we'll get you in here too, of course. But let's tie this in because, like, less than an hour later, the announcement and the reason we're 99% certain this is a pure coincidence is that these seat swaps take time to like coordinate and schedule and figure out. So this didn't happen in the hour after Rogozin left Roscosmos. But NASA has confirmed that they are going to fly NASA astronauts on 2 Soyuz missions that are coming up, and Roscosmos will get to fly 2 cosmonauts on 2 Crew Dragon missions.
Otherwise known as ding, 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 the thing we've always been saying would happen and waiting for, but the Russian political situation interfered with that quite a bit.
Right. And so the schedule looks like this. It's actually the next crew launches are going to start this, and which probably means that they've been in the works for a while and now they're just final. But Soyuz MS-22 is launching on September 21st of this year, and NASA astronaut Frank Rubio is going to join a pair of cosmonauts on that mission. Around that same time frame, the SpaceX Crew 5 mission is going to launch, so the U.S. segment rotation, and that will include cosmonaut Anna Kikina, which is, I believe, her first space flight, and it is notable that it is rare to have a female Russian cosmonaut, but Anna will be flying on a Crew Dragon mission alongside Nicole Mann and Josh Casada from NASA, as well as a JAXA astronaut. So that'll round out the Crew 5 mission. Those are the 2 crew launches that are left this year. And then moving into next spring, Soyuz MS-23 is going to host NASA astronaut Laurel O'Hara, and then also in that spring, SpaceX Crew 6 is going to include a cosmonaut alongside 2 NASA astronauts and a to-be-announced crew member for the UAE as well. So there'll be another international partner on that mission. But
another reason I think another reason this is not a surprise, but just okay, good, we're finally going to acknowledge that it's happening, is basically that Anna Kikina has been seen in photographs training for Crew 5. Along with her, just in case this doesn't happen, replacement in Jeanette Epps. And then we've also seen Andrei Fadeev training for Crew 6 as well with NASA. So not a surprise to see those 2 actually getting confirmed. And of course, the other cool thing is, the JAXA astronaut Koichi Okada. This will be that will make several Japanese astronauts who have visited the space station for long duration missions since the Crew Dragon program began. And then also what's noteworthy too is that Crew 6 will include a member of the United Arab Emirates astronaut corps going up for a stay on board the station as well. And that is also really nice, but also really interesting to see, because the UAE sort of, for those who weren't really, keeping up with them, came out of the blue all of a sudden with a mission to Mars and a crew flight to the station on Russia, but they are really making a presence for themselves and really want to ingrain themselves in the international spaceflight community and showcase everything that they can bring to the table. So that's also really cool to see as well.
Yeah. And of course, and I think we can do some brief commentary. There's also a question here. There's definitely been a lot of discussion about whether the seat swap is a good thing. Anyone who has been talking about this discussion on social media for the past couple of days knows that there are certainly people of the opinion that NASA should not be seat swapping with Russia and should actually be working to cut ties with the Russian Space Agency with regards to the ongoing current events in Ukraine. Also, there's the other side of it that says spaceflight is supposed to be above that, no pun intended, that spaceflight should be not affected by political or world conflicts, and that international cooperation in spaceflight should happen regardless. Any quick thoughts from either of you on that discussion before we take a couple questions and keep going?
Yeah, I mean, I definitely understand where those feelings come from, right? Based on the geopolitical realities of what's here on the ground. But at the height of the Cold War, we met the Soviet Union in space,
Yeah.
and you know, I personally tend to look at that as that's the way we should go. So to me, I am happy to see that sort of cooperation is continuing, and that we do have things that we're still trying to figure out. Most notably, I think the Spectre RG telescope between Europe and Russia is one way to look at that, to say how the relationship is still muddied in some way, but I'm glad it's not affecting human exploration cooperation at this point.
Hagen, you too? Any thoughts?
Just the same thing as Chris just said there. I love the reference to the Apollo Soyuz project there, because I feel like that's something that we can really use to sort of
Which
guide us through, this seat swap and everything.
which
I
actually
have Apollo
But
Soyuz
yeah,
pictures
just
behind
echoing
me.
everything
I don't know
Chris
how
said.
well that comes out on the resolution that we have this picture, but they're right there. Anyway, sorry. Go ahead, Chris.
because today is actually the anniversary of Apollo Soyuz docking.
No, it's not.
July 17th, 1975 at 1619
Really?
UTC is when Apollo and Soyuz docked with one another.
Oh my God, it is.
Yep, it is the anniversary of that mission's docking
Wow.
today.
We didn't plan that.
No, we didn't. Well, as soon as we started talking about it, I was like,
no.
wait a minute. It
Wait a
launched,
second.
well, I was like, wait a minute. It launched on July 15th, so a 2-day phase. Yeah.
Yeah, that's about right. That tracks. Huh. That's funny. Well, there we go, chat. We did that all by we totally planned that. All calculated, worked it out on our own. Let's see. And then we do have one question here, and this is an interesting conversation point. NASA is asking SpaceX to fly cosmonauts on 2 missions. Does SpaceX get any say in that, and can they say no?
I do not believe they can refuse that, because international presence on Crew Dragons was always part of the plan, and SpaceX is not a SpaceX is literally just the ferry service at that point. So no, I don't believe they can say no, and everything would have been designed the same way. And I would also say, ask this question of yourself in reverse. Why would Roscosmos have a valid security reason for saying no to putting an American on a Soyuz? We've already been on them, right? This sort of international presence was integrated into the design of Orion and Dragon and Starliner to begin with. So why would there be an issue there?
Sure. Obviously, we've talked about this a couple of times on a couple of shows now. The war in Ukraine is going to have an ongoing effect on spaceflight. We're starting to see some reports starting yesterday that the plant that develops the Antares first stage and the engines on Vega has been hit by missile strikes. I mean, there's going to be ongoing effects from the conflict in Ukraine. So we're going to keep talking about this, but obviously we want to focus on the science that's being done and the missions that are launching rather than the politics surrounding it as best we can, because that's what we know best anyway, and we don't want to offer commentary on things we're not experts in anyway. But definitely worth mentioning, and I think we can all say that we're looking forward to the Crew 5 mission and MS-22
Oh gosh, yes.
and seeing those flights go. So looking forward to those launches in just a couple months, actually.
And this makes total sense, because one of the ways the ISS contracts were always written is that there should always be an American, there should always be a Russian on board the station, no matter what. So if Americans are only launching on American craft and Russians are only launching on Russian craft, and there's a medical emergency and you all have to pile in the craft that got you there, that could leave months of time when there's not an American or not a Russian. So this makes sense for both organizations to keep this up, so that you're not caught in a weird situation because of a medical emergency.
Right, sure. Before we move on, I got a couple more super chats and other support that I want to thank really quick. Jim Kevitz says, thanks y'all, good to have Hagen today. There you go, Hagen, you get the shout out from Jim there. Appreciate the support. Alex Gar with some super chat support as well. Thank you so much. Here's a quick question. This goes back to James Webb quickly, but Chief Sway says in CT imaging we use algorithms to remove artifacts such as metal artifacts. Can they post-promise the images from James Webb and remove those spikes because there could be something behind an artifact that we can't see? Is that possible?
Oh, oh yes. It's possible to get in and work with images from telescopes, remove artifacts. In fact, if we can actually go back to, in fact, if we have them easy to grab, the Jupiter images that we showed earlier are great examples of what some of these images can look like before noise is filtered out, right? Before you start pulling out, okay, this is what this saw, this is what this saw, this is what that saw. That's actually a more, that's what it looks like image of Jupiter. And those are actually some of the more, that's what it actually looks like before you start processing them and removing various pieces of noise. So yeah, you can definitely get in and work with images and clean them up if you need to.
Right. And a couple more things. Musical Wolves asked, does this mean no more broomsticks? And Meaningless says that Rogozin got swept out. Come on, chat. Come on, man. Oh, this one. There's so many puns in this one. He got bounced out on the trampoline and swept out on his broom. And also, they're saying that we need to add the trampoline to our broomstick shirt.
Yes, as the launch pad. We should actually, yes.
Oh yeah, that's a good idea.
Kevin Kramer has gifted 20 Red Team memberships. That's a lot of memberships
nice.
and a lot of support. So, Kevin, thank you so much for that. We appreciate that. And Hamster Spacer says it's also his birthday today. I have a special birthday. Hamster, thank you so much, and a happy birthday to you. Glad you share your birthday with Apollo Soyuz. But thank you for the support. There's the broomstick shirt. There you go. Thank you, Michael's on top of it. If you haven't gotten your broomstick landing shirt, maybe this will be a limited edition thing because we got to add the trampoline now. So maybe this is your last chance to get this version of the shirt. I don't know, but you can go check it out on the NASASpaceflight.
You can celebrate a change in Roscosmos leadership with your own broomstick shirt.
There you go. Okay, so I want to touch on a little bit. This is a very brief bit of news, not too much discussion to have here because we don't actually know that much. But Virgin Galactic made 2 announcements with this weird phrase in them: Delta class spaceships. This is the first time the company has mentioned this phrase. We don't know anything about them. All they say is that they are partnering with Aurora Flight Sciences, which is a subsidiary of Boeing, to develop 2 new carrier aircraft. That's what we're looking at here. I don't know if this rendering is of the new aircraft and they look very similar to White Knight 2, or if this is we put the new logos on a rendering of White Knight 2, but the new ones might end up looking different. We don't know. But that is the carrier aircraft of Virgin Galactic. And then they're also announcing that the assembly facility for these Delta-class vehicles is going to be in Mesa, Arizona, and they showed the location of that assembly facility. Chad is telling me that the Delta-class isn't super new. They talked okay, here, maybe you guys can correct me. There was Spaceship 2, that's already flying, and then they mentioned Spaceship 3. Spaceship 3 is not the same as Delta-class, is it? Or did they just give it a new name?
It's the new production vehicle, as far as I'm concerned, but I think they're the same as far as
so maybe that's what messed me up. I thought Spaceship 3 and Delta were 2 different things. I missed the new name apparently. See, this is why we have Chad involved. Chad can correct me, and our backroom can correct me when I'm saying something that's wrong. Okay, so apparently that's the Spaceship 3 thing, and we saw a render of Spaceship 3 that looks more or less the same as Spaceship 2, like it looked a little shinier, like it looks like the materials might have been different and stuff like that, but the shape wasn't drastically different, so maybe it's more or less similar and a more optimized version. But yeah, any thoughts on Virgin Galactic potentially? I mean, they haven't flown in a while, and I don't think they're supposed to fly till next year at the earliest, so any quick thoughts on this?
Well, that is sort of my thought on this. Both of the releases, both for the mothership, the new mothership, and the Delta class spaceships, both talked about being able to support up to 400 flights a year. It's worth noting it's been over a year now since they last flew. We know the reports that sort of came out after the last one about the issues during the flight, violating a red line limit, violating the FAA airspace closure. It was not the stellar flight that it appeared to be visually, right, with the champagne pops and everything, and they haven't flown in a year. So all of that is really good. I want that to be true, but they got a long way to go. If to bring that to fruition, and we need to see what the safety changes were that they have made. But I will say this, that it does sort of match what we heard. I think it was like September, October of last year when they were going to fly again, and the FAA said no, and they said yes, and then the FAA said no. We have final say of that, and then they sort of decided, okay, we're not going to fly until the next generation is we're going to basically move on to the next generation, was sort of what they said. So it's good to see that starting to come to fruition, but they've got a long way to go before what's in those releases comes to pass. And I want them to. Don't make that comment wrong.
Right,
I want them to. Yeah, but they got a long way to go.
Yeah.
And probably worth mentioning that their biggest competitor in Blue Origin has been flying how many missions in the meantime? And that's got to be some sort of financial pressure on them. Although the market's pretty new too. I'm not a business expert. I'm just pointing out that comparable systems of comparable role are also flying. So chat's also pointing out, see, this is where I was thinking, saying Delta's the fourth letter in the Greek alphabet. That's where I was thinking. So I was like, oh, clearly it's after Spaceship 3. That naming makes sense to me. Apparently I'm just wrong. So whatever. I can't
But then
be
you've
right
got
all
like
the
the
time.
Delta wing design. You've got,
Right, yeah. So who knows where the name came from? I'm gonna have to
Yeah.
go back and read some new Virgin Galactic stuff to catch me up. Apparently, I did mention that we were going to do a launch recap, and it's already 4 o'clock, and we've got a whole Starship thing to talk about. So I think I'm going to move the launch recap to the end, and we'll get there. But let's do some Starship up next. So the big thing is, of course, our good friend Booster 7. And the unfortunate accident it had a couple days ago when it just tried to do some engine testing. It was rather unfortunate. Me and Chris were on stream at the time. Our reactions were funny, I'm sure, for many people. But for those who are just tuning in, Booster 7 did go through some engine testing on...
Yeah, unexpected engine testing is maybe the way we should phrase that.
So, an unplanned detonation of a fuel-air mixture near the base of... And there's the audio. Not great. So the upshot of all of this is, first of all, at the time, what we were expecting was maybe a spin prime test or something like that. They were loading propellants onto the vehicle. The bottoms of both the methane and liquid oxygen tanks were frosty, so something was loaded into both of those tanks. Liquid oxygen was more or less expected because for a spin prime test, we would expect liquid oxygen to flow through the engines. My initial speculation, and I'm going to mark myself as, hey, Thomas was wrong on stream, that I was like, oh, the methane recondenser never turned on. So they're probably loading nitrogen into the methane tank instead for either thermal considerations, or maybe they'll flow methane through, or nitrogen flow instead of methane, so that you can't have a propellant mixture. And this can happen. Clearly, that's not what they did, though, because it did happen. So methane was loaded at some point where our spreadsheet excerpts is going to have to... take a look at what the fueling timeline may look like now, because maybe the recondenser is involved in a different way now, or maybe there was another methane source or something. Regardless, a fuel-air mixture was created in the engine section, right? And then some ignition source lit that ablaze, and that is going to cause some damage to the bottom of the vehicle. After the fact, we heard from Elon Musk, who said that the damage looks relatively minimal. However, they are going to move it back to the production site, which they have now done. It's back in the Mega Bay in order to be inspected, and I believe we also saw them at least swap one Raptor before that roll even happened. So engine swaps are probably a pretty likely outcome here. Here we go. Here's the direct quote here that's saying that cryogenic fuel is an added challenge because it evaporates to create that fuel air risk. So talking about the methane fuel that could boil off and cause a mixture. Also noting that there should have been sensors to detect this that didn't do that. So that's going to be a focus of the work back in the Mega Bay as well. But yeah, hopefully the damage is relatively minor, and that's the hope that Elon's been projecting on Twitter as well. We've got Booster 8 in the works as well. That's been being stacked at the production site. So obviously if Booster 7 was damaged beyond repair, they'd have that option. They've also got Ship 24 testing to work on in the meantime. So I don't think Starship testing is going to ramp down in the meantime. I think they're going to be able to pivot to ship testing while a booster, whichever one it ends up being, gets prepared to go out to the launch site and resume their test campaign. But let's start with some initial thoughts from Chris and Haygen while we get into some more questions. So Chris, you want to lead us off? Thoughts on the latest testing developments?
Well, it definitely reminds all of us that even on tests that you're not necessarily expecting anything to go awry with, these are new systems and they're still learning procedures and they're still learning sequencing of some things. I think the biggest sort of eye opener was when Elon said that it was a fuel air explosion risk. I mean, that was sort of eye opening to me because exactly what he said. There should be sensors there that should catch all of that, right? That should catch high concentrations of methane that would potentially lead to that type of a risk that obviously did not work the way they were intended there. So whether that means there need to be more, they need to be repositioned. We'll see if Elon is a little forthcoming on exactly how that went. But I mean, honest to God, my first thing when this happened, I was not actually staring directly at the image. I was reading something else because I think we were ironically answering a question about what the radial outward firing initiators on liquid hydrogen engines were at the moment that this happened, and we should have just gone that as the reason you want those firing systems, which Elon mentioned might end up having to be a thing for this as well. We'll have to see, but my first thought when it was there was that I was just relieved that everything was still standing, because that could have been a lot worse. That could have been a lot worse.
Yeah. Hey, you'd want to chime in here before we dive into some questions? They're already coming in, but
well, I obviously wasn't on the stream. I was actually simultaneously trying to tweet and download JWSC's first image when I got the notification
that was the same day.
7's engines had exploded. I was literally tweeting out the first image as its engines went off. I was like, "Nice, this is awesome." But just basically everything Chris said there. I feel like we sometimes get so used, especially with the lack of testing over the past few months. We often forget that this is a test program. Things have sort of become so streamlined and have been happening so smoothly down there recently that, or relatively smooth. I'm not going to say it's been going perfect, but that we forget that stuff like this or like stuff like SN4 can happen. Thankfully, this was not as bad as SN4, but it was very SN4-esque in a way. And, that's scary to think about. And just same thing that Chris said, very, very, very happy that everything is still standing. There wasn't any substantial damage to the booster. That's good news in terms of the whole program and pushing for the orbital flight, though it may now be delayed by a little bit. But yeah, just quite a shocker. I know definitely it was a shocker for me. I know it was even more of a shock to y'all on the stream. So, but overall, just happy everything's okay, and just curious to see how things are going to go throughout the next few weeks as they continue to cope with this event.
Mm-hmm. And Hamster Space Nerd, we probably deserve this, though, says, you guys need to stop saying there's no methane in something because every time you do, something explodes. Listen, it's not our fault. It's a coincidence, and I took responsibility, okay? Jack feels bad about SN4 as well, I promise. That's so bad. All right, we've got some questions starting to come in here. Katashi asking, how far away is Booster 8? What is the latest Booster 8 status? I believe it was stacked at the production site. But what kind of forward work would we expect from that, and how would that tie in with the decision of are they going to fly or are they going to test Booster 7 or Booster 8 instead?
Well, we would need Raptors. Last we heard there were enough for Booster 8, which we're thinking might be, depending on exactly what the forward path is, they might grab the ones that were for 8 and stick them onto 7 if they need to actually inspect the Raptors more that were on Booster 7. It might be easier to just simply swap them out with new ones that are there. But it would definitely need its engines. It definitely needs some more outfitting campaigns and finishing up tasks before it would be able, or before they would want to move it out to the pad. I honestly think a lot of it is going to come down to how quickly they can swap the engines out, because one good thing that we did hear from Elon so far is that the damage did appear to be minor. So he didn't really mention that they were thinking it would take an incredible amount of time to get this inspected and back out to the pad. I believe he even said a week at some point is what they were thinking of. So I don't necessarily think at this point we're aiming for a swap of the boosters, but I mean, that will ultimately come down to just how damaged 7 actually is.
I agree, and this actually comes to another question from Paul, who asked, do you think they would risk flight with Booster 7 even after these issues? Is it worth just even trying to repair Booster 7 when they could just go with the Booster 8 instead?
Yeah, I mean, especially if there was no significant structural damage to B7, if it was just that potential. I mean, we did definitely see the engine shield ring was cracked when it came out of there. Oh, yeah, hello, kitty. See, cats like space too. That works as well.
I was wondering when this cat was eventually going to make an appearance on NSF Live, and here she's going to try and jump onto the windowsill now. Do you need to be closer? Oh, nope, you're gone. All right.
But
Sorry for the interruption.
But the important thing is that this did not appear to be something that was. I mean, just from the outside, right? It was a fuel air explosion risk, which means it wasn't something internal to the engines that kicked off the explosion. It wasn't something internal to the booster that kicked off the explosion, which might actually work in their favor, because if this ended up being something that was a procedural error and something that is more or less easy for them to correct and move forward, then there wouldn't really be an issue or an added risk to reuse the booster, as long as they do their due diligence and do the inspections that they need to do down in that area to make sure it's still safe. Then it's just a booster that needed a new oh my gosh, why can't I remember this word? A good protection ring around the engines now, whatever that's called, because brain's not working. Shroud,
no,
thank you.
Is it shroud? I guess
the engine shroud.
Yeah.
Yes, the engine shroud. Thank you. Yes.
Right. So that's a good points there. Also, here's a great question. We were kind of showing some footage of this earlier. Any info on the secondary explosion and fire? I don't know if there was another explosion, but there was a fire at the pad that developed afterwards, and in that fire we heard some like popping. It sounded like some small tanks might have been going up, if there was like some welding tanks or hydraulic, some small containerized thing that if there was a fire around it would pop. We were observing that. Obviously, we saw that it got extinguished, and I don't think either Mary or Nick have observed any like substantial damage to the pad area from that. So hopefully that means that it's pretty minor. But I don't know if we've heard anything more specific than that.
I did not hear anything more from SpaceX personally on that.
Yeah.
No.
I'm gonna keep questions coming about all of this. Got a couple of chats coming in here. Andrew says Delta sounds like a character from BioShock. Fair. Musical Wolves. Booster 7 couldn't handle the when hot pressure, so just wanted to answer by launching. Also, why did it happen at 420? I don't know. Why does anything happen at 420? It was a coincidence. Pal has become a launch director member. Pal, thank you so much for the very generous support there. We appreciate that. It goes a long way to help us do what we do.
Oh yeah, that's that launch director. Thank you. Yeah, that's incredible. Yeah.
Chat's asking for a YouTube short of my reaction to the anomaly because it's meme worthy. I don't know about that. It wasn't that funny. Oh, here's a good point. Dr. Holly. Wait, is this the Dr. Holly? This has to be
Dr. Holly.
Dr. Holly. Yes. Hi, Dr. Holly. Who says minor damage because it was a fuel-rich explosion. Had it been closer to stoichiometric, things could have been much worse. That is a very good point. Would it be fuel-rich? Wouldn't there not? Wait. Would it be fuel-rich or oxidizer-rich? Because wouldn't the environment be oxygen-rich in that scenario? Maybe I'm thinking
But
about this wrong.
but it's the fuel that.
I guess it depends on where the ignition source was.
Well, and outside, right, a fuel air explosion would would be a fuel rich. Right?
Yeah, I guess it would be. But regardless, that is a good point. That's that was not the full blast potential of that situation.
No, it was not.
Close.
The fact that the booster was still standing is good evidence that it was not as powerful as it could have been.
Right. Here is a great question here. So, and I'll bring in the technical term for this question, but I appreciate the way the question's worded. Are the hydrogen spark things good for usability? I know exactly what you mean. So, if you looked at, let's see, Shuttle is probably the most obvious example. SLS will have very similar systems. They also have them on Delta 4 to burn off hydrogen near the base of that vehicle. When those engines prime their systems, hydrogen goes through the engine, and hydrogen can build up near the base of the rocket. So before you actually ignite the main combustion chambers, you fire these things called ROFEs, which are spark generators, basically, that will burn off some of the hydrogen in that engine bay before the actual ignition occurs, and that controls the fireball. Obviously, Delta 4, we still see a pretty significant fireball, but it's mitigated, and it's to the point where it's safe. And while Methalox engines are a fairly new thing, the Raptor engines will have a similar process. And I think beforehand, SpaceX was expecting that a spark system would not be necessary. But Elon later said that we are going to add that kind of system to the launch mount or at least they're going to add that system to the Starship architecture. He wasn't very specific, but it sounds like they're going to go that way. The question, however, how does that system lend itself to reusability? We saw that system fire multiple times for a Delta IV Heavy launch campaign, and that system was actually it was the reason that the turnaround time was whatever distance it was, because they had to replace the ROFEs. So how would that system lend itself to a rapid launch cadence from Starbase, for example?
So it would depend a little bit about how you design the overall system, the propellant that's going to be used to generate the sparks. The issue with them on the Delta and the shuttle pads is that they were basically cartridge charges, right? That once you ignited them, they were solid. You couldn't turn them off, so they would just burn, and then you had to go back into the system and you had to swap them out. And depending on what part of the Delta system you were in, that could be either 2 weeks or 7 days, depending on where they were. But you could also potentially design the system so that those propellant lines were flowing up through your ground architecture. So just like the TTAB system that is used to ignite the Merlin 1D engines. Right, the Falcon 9 does not carry all of the TTAB to ignite all 9 of its engines. It only carries the TTAB to ignite the 3 that need to reignite midair for the entry burn, and the one that needs to relight, the center engine that needs to relight for the landing burn. All the other TTAB for the actual first ignition of those 9 engines on the ground is provided through the ground propellant systems and the ground system. So in that regard, you could look at a system that could be designed for that rapid reusability in mind, instead of having to go out and replace a cartridge that takes 24 to 48 hours to repair.
Right, okay. That's interesting. Well, so I'm interested to see how they actually implement that in the launch mount, like how quickly, if they make that a priority.
Yeah.
Given that this is before now, it seemed like they weren't even thinking that was going to be a necessary feature. I guess he also mentioned the sensor deal, and they could, in theory, investigate why the sensors weren't giving them the readings they would expect, adjust how they handle the sensors in the engine bay, and then go, okay, we no longer need the spark things because we'll know the methane levels and we'll be able to be confident that it's mitigated or whatever. It could also be a combination of both, but.
Yeah, because we could be seeing like that this is just what the system with 33 Raptors produces, right, to get them chilled enough. So maybe this is something that you're exactly right, Thomas. Like this might be something that maybe it was a sensor thing, but maybe it's a ventilation thing, or maybe it is something new that, oh, wow, we do need those.
Right, sure. Another question that's come in here, a quick question, did a notice go out to Mary and Nick when they did the fire test? The answer is no. Which is why we were all like, they're not going to ignite anything. There's not going to be methane loaded onto the vehicle. And SpaceX made me look dumb. It happens sometimes. But no, there was no notice, that does confirm that there was not supposed to be an ignition source. There we go. But another question here. Any word from the FAA after Booster 7? Yes, actually. At the FAA, and it basically said what we would expect. They said they are obviously aware that the anomaly occurred. They said they would be tuned in to the findings and how SpaceX testing progresses. However, it's not really their jurisdiction because it wasn't an anomaly during like an FAA licensed launch. It was a ground test that the FAA does not particularly authorize. And so they don't have jurisdiction for the investigation, but they're still going to be in tune with it because it'll be part of SpaceX's process for getting a launch license. And so that was basically the summary of their comments. And this doesn't like revoke their environmental assessment or anything like that. There's not going to be any immediate effects from the FAA side of things from this test. But a very good question. Let's see. There's a couple more. Oh, first of all, Dr. Holly pointed out there was soot visible on like the launch mount and stuff, and that's the sign of incomplete combustion. So, Dr. Holly, thank you. It's been a while since I took chemistry, so I appreciate the help. And yeah, so that's a good point to that discussion. Let's see. So Weston asking if the source of methane was the spin test and the source of oxygen was the atmosphere, how could sensors solve the problem? Well, sensors would tell you that a problem is there and that you should make sure there's no ignition source, you know? It would tell you whether it's safe or unsafe to fire the igniters, for example. It wouldn't solve it might not be able to solve the root problem, though. It depends on where the source of those commodities were. So it'll depend. But yeah, good question. All right, I'm going to look for a couple more questions here. We've got a few minutes. Maybe we'll be able to get back to that launch recap as well. What exactly do we watch to determine if the methane recondenser is active? A bunch of, I believe it's nitrogen vapors come out, right? Chris, do you remember? I know we see vapors come from the system when the system is active. Nitrogen vapors. Michael,
yes, nitrogen vapors. Yeah.
And that's a result of the thermal conditioning. Basically, for those that don't know, the methane recondenser's job is to take methane that is evaporated into a gaseous form and condense it back into liquid form so they can reuse it rather than just venting it. So there you go. Answers that question. Chat saying, please pet the cat. The cat keeps walking in and out of the room. Apparently I should have closed my door, but I think Chad liked that the cat made an appearance. So, and here, we'll take this as the final question with the Starbase section. Any information on the progress of the FAA mitigations that have been asked of SpaceX?
Yeah. I think this is going to be an ongoing question that we keep getting. I think the biggest thing to bear in mind with that report is that quite a few of them were already A, underway, and B, complete by the time we saw them all. Some of the things were already things they had to be doing, but that by law have to be mentioned. You know, it's like the sea turtle stuff, right? Like all the sea turtle stuff is that some of them we're not going to see yet, right? Because some of them were like interfacing with the local school board for X number of field trips. You know, Well, it's summer, you can't do that.
How cool would it be to have a school field trip to Starbase? Anyway, continue.
Exactly. I mean, hey, the schools around the Kennedy Space Center go to the Kennedy Space Center. I mean, right. I mean, it's like a rite of passage here. So yeah, so some of those things can't happen yet because of the time of year we're in. Some are things they were already going to have to be doing, and some of them are things that don't necessarily have to be done unless there's an anomaly, not the kind of anomaly that we saw earlier this week, like a full boom anomaly. But so yes, there are things that they're working on. There are obviously things that have to be done before the orbital flight test can occur, right? But none of those that we saw that have to be done before then were things that we went, oh my gosh, they can't have this done. You know, they were all of very common sense things that they'd already sort of be doing, or like, okay, we tweak this if this happens. You know, things like that. So yes, they're making progress, but it's not like we are waiting for number 78 to get checked off, and once 78 is checked off, boom, we can hit the big red button to launch it. It's not like that, which makes it a little frustrating, I know, when you're trying to ask how far along are they, or do they have enough done. The basic answer to that is yes. You know, it's not going to be this that I don't believe it's going to be this that holds them up now. It's going to be the testing and the hardware readiness at this point to get off the ground.
Sure, yeah, I think that's fair. So things to look out for. Let's preview what we should be looking at now for Starbase. Obviously, we're going to keep an eye on Booster 7 repairs. When is Booster 7 going to be ready to return to the launch site? Or, and/or, I guess this could be an and/or, Booster 8, when will it head out to the launch site for its own test campaign? Will it wait till Booster 7 is done? Could they go into a dual flow? Could Booster 8 take Booster 7's place? Anything in between. Ship 24, obviously already out at the launch site. We would expect spin prime testing, hopefully less eventful spin prime testing, and then moving into more engine testing for that vehicle. I believe, correct me if I'm wrong, we did see a question in chat. Ship 24 could launch on Booster 7, right? They're not like incompatible or
8.
anything. Right, or Booster 8, that's what I meant, sorry.
Yes.
Yeah, it is. Doesn't matter which booster it goes on. I know in the past we've heard that as they upgraded the two, some of them couldn't go with one another, but Ship 24 is agnostic, if you will. So 24 testing is definitely something to keep an eye on. And then also, if you have not seen the KSC flyover video, Starbase Kennedy, which I know is not the real name, but I'm just going to use it, is under construction as well. 3 tower segments still out there. We are awaiting word of the next tower segment to roll out, but we'll keep an eye out for that, of course. And they might roll out 2 out at once with that highly advanced simulation Jack put in the video. If you haven't seen the video, go watch
That
the
was
video.
good.
But they are in final preparations for some more segments to roll out. The chopstick arms, or at least one chopstick arm, I think, has been spotted out there. And yeah, myself, Julia, and Steven took a flight this past week. So go ahead and check out the video. You would, I think you'll enjoy it. But that's that. Oh, also they're widening the road, which explains why they stop in front of the VAB every time, because it's really narrow there. So
Not
that's
surprised.
yeah, yeah. And that'll not only help the construction process, that'll help them roll out vehicles in the future. So there's your plug for the flyover video. Highly recommend checking that out. And those are the items to watch for over the next week. And we'll give you another update the next NSF Live, of course. But I think that's our Starship update. Let's circle back and let's end off the episode with a recap of all of the launches that happened this past week. There has been a few, and we're going to start off with our good. Let's see. All right, no one in this call is a huge fan of Vandenberg, so we can say the least coast and the foggy
Oh,
coast.
Vandenberg. Fuck.
So Vandenberg Starlink launch. Sorry, Michael.
Look at that crystal clear image.
Wow.
although that is an incredible shot.
That's
When
a
they
cool
do
shot.
that, yes. Yep.
Maybe
But-
Michael muted me because I talked bad about Vandenberg.
But just in case you're still muted, because Thomas, sorry about that. We can actually hear Thomas absolutely fine on our end, so we did not know that he was somehow muted for the stream. So, sir, hopefully you are hearing me as well. But this was the Starlink 3-1 mission, which was more of the polar trajectories for getting those for continuing to deploy the Starlink constellation and build out the constellation into its various shells. We've seen some of the 4 ones go, some of the shell 4 ones go from Vandenberg here using a dogleg maneuver, and now we saw some of the 3 shell getting up there. And that was sort of the beginning of a week that was bookended by Starlink missions. Just this morning, we had 422 go from Cape Canaveral and Slick 40 here at the Cape Canaveral Space Force Station, getting up another Shell 4 group of 53 Starlink satellites, and we could see that one launching this morning. This one kind of threaded a 50-50 weather consideration. So basically, it was literally a coin toss. Could be good, could be not. We have a little tropical moisture and frontal system sitting near us, which caused the weather. And that one got up just fine this morning. 13th flight of a booster again. But that one got up just fine this morning, closing out our week. And we had another Starlink. We had another SpaceX one that was a little bit earlier in the week. Thomas, I know you and I rolled out for CRS-25, the 25th Commercial Resupply Services flight of cargo, crew supplies, and science to the International Space Station. This lifted off 22 minutes after local sunset at the Kennedy Space Center. And it not only did the jellyfish, it did the second stage contrail all the way to engine cutoff and orbit insertion. There are just moments when the flight trajectory up the East Coast on a Northeast station trajectory aligns perfectly with the sun angle and Earth's axial tilt from this time of year, because just about 2 minutes into flight, Falcon 9 broke back into daylight and then barely never left it. It just basically rode that curvature of the Terminator there up to orbit and did a gorgeous job. Thomas, I mean, it took me by surprise, but I didn't dare take my eye off the viewfinder because I was doing our track. I mean, what did this look like to the naked eye, to you sitting there?
It was incredible, and I mean, I think though I was actually simultaneously watching with my own naked eye and watching Chris the monitor tracking it, and I think the track brought it out beautifully, and obviously the zoom. Mark one eyeball, to steal Das's phrase, can't zoom in. But yeah, it was an absolutely gorgeous view. It was a beautiful launch. Haygen, did you actually catch a glimpse of it from where you were?
The clouds decided to come out the one day of the year where there was going to be a beautiful twilight launch for me to see. So no, I was unable to see it. I was very, very, very upset about it.
Well, we're gonna have to get that. We're gonna have to.
I watched the live stream. It looked beautiful. Real jealous of y'all.
Yeah, we'll have to get a future jellyfish effect on up there towards you. But this is the shot. This is coming up on Miko, and we'll show what this looked like from here. And also, thank you, Michael, for releasing me from my mute stain. Unfortunately, I'm not allowed to talk trash on Vandy when Michael's producing, apparently. But yeah, it was a beautiful launch, and a quick preview for those of you who are YouTube members. You're going to get a quick behind-the-scenes look into this launch. There was some cool footage that I was shooting during this launch campaign of remote camera setup and our live stream coverage and things like that. So if you are not already joined the membership program, that is one of your perks. You get to see some exclusive content such as behind-the-scenes stuff. So I don't know if that's available yet, but it will be available to YouTube members shortly. Chris tells me it'll be available shortly, and so stay tuned for that. And that's a cool membership perk. And thank you to everyone who, of course, supports us that way.
And you also want to give a shout out to WD40, one of our friends from the Twitch streaming community, who was down with his IR camera. So this was actually from his camera, and then we were able to switch back and forth between his and the one we had at the press site, which was really cool to see IR versus visual. Or wait, not an IR camera, just different angles. Sorry, I totally thought I saw IR camera at one point earlier in our conversations about this. My apologies. But just a different angle on this. I really loved flipping back and forth because, man, the booster just did so many cool things, and you almost never get to see on the booster landings, that we still have it visually.
Right.
When it passes the second stage in the linear trajectories, because they're all just following, ballistic trajectories at that point. The booster just shoots up a bit higher than the second stage and then comes back down. And it was really cool to be able to see the booster pass the second stage, because when I realized that was going to happen and we still had visual, I remember turning around to you, Thomas, and going, tell them on stream that we're going to get this.
Yeah, of course. So there we go. All right, so hold on. So we talked on both Starlink missions and CRS-25 that handles the SpaceX business for the week. 3 launches from SpaceX in a single week. They don't do anything these days.
Actually, I mean, seemed low. Where was the 4th?
Right, yeah, honestly, sometimes it is 4. And then we had 2 other launches that were very close together, actually. The first one from our friends down in New Zealand, Rocket Lab, launches the WISE 1 Looks Ahead launch, which was their name for the NROL 162 mission, so a mission for the National Reconnaissance Office. And this is actually notable because it is the first of 2 back-to-back missions. They're launching another one this coming week, at least that was the original date, subject to delays, of course, but they are planning 2 back-to-back launches for the NRO, and they're trying to demonstrate an increased launch cadence and the ability to sort of responsively launch, because that's a big a big sales point, I guess, is what you would say, especially for small satellites. The ability to get small satellites that are quick to make, also get them on orbit quickly. And so that fits right in with Rocket Lab's mission of delivering small satellites to orbit. They had a perfectly successful launch. No recovery attempt on this flight. Still waiting to hear on when they'll be able to make that attempt next. But they are continuing to fly missions this year, and they'll look for another one this coming week. So that was that mission. And then right after this, that same morning, was the maiden flight of a brand new rocket. Chris, our friends over in Europe have a new one.
Yes, Vega C made it off the ground successfully on its very first attempt. It ended up needing most of the launch window, though, for some technical things that they just, Take your time. Make sure you always want to be on the ground wishing you were flying, than in the air flying desperately wishing you were on the ground.
Yes.
But this was a debut of a new Vega, because I'm sure people are going like, wait a minute, Vega, I've heard of that before, Chris. It's not a new rocket. But the Vega C is a new rocket. So it utilizes an enhanced and beefed up first and second stages. So the first stage is now the P120C plus, the P120C, which is the same exact motor that will be the side-mounted boosters on the upcoming Ariane 6. So no changes there. Literally, they just changed the adapter. Instead of the interstage adapter connecting the first and second stages you see here, they take the motor and they slap a nose cone on it and put it on the side of the Ariane 6, and you're good to go. In that regard, but it had a very highly successful flight. Only the third stage is exactly the same from the original Vega. The payload fairings are bigger, the second stage is bigger, the first stage is bigger, the Avum Plus cryogenic upper stage has more capability as well to it, and upgrades and enhancements. So really good to see that mission take multiple satellites to orbit into different orbits as well, but wonderfully successful mission for them, and really paving the way for the introduction of Ariane 6.
I do have a question about the new rocket versus not new rocket.
Oh,
question.
sorry, one more thing. Onboard camera views. They showed us onboard camera views of this thing on all of the stages, and just, mwah, thank you, Issa. Thank you, Issa. That was so good to see. Oh
that
my
was
gosh.
very cool. I hope they continue to see that on future missions too. But Alex in chat says it's Vega C, but when it lights its first stage, it's Vega no C. It does
Yes.
get out of there pretty quickly, just like the other Vega.
It really did. Someone actually asked me this on Twitter, and we did the math for the Vega C, and I have that. If you will just give me one quick second to actually find the image. It should be easy to find since there's a Vega in it. But yes, basically, this vehicle is a lot more powerful than the original Vega. So the Vega, so Vega C has a thrust to weight ratio of 2.18 to 1 when it lifts off. So yes, it gets out of there very quickly. And for comparison, the original Vega had a 1.68 to 1. So almost a 0.5 increase there total in its overall thrust to weight ratio. So yeah, it zooms out of there.
There you go. And the beauty of solid motors.
Yes.
But so back to the question I was going to ask you is, Vega C, is it more akin to, I don't know how I want to phrase this. Is it the same thing as like Falcon 9 going from Block 4 to Block 5, where it goes from Vega to Vega C? Or is it more of a completely different rocket?
More of like a block upgrade for a liquid-fueled
sure.
vehicle. Yeah. I mean, the first stage motor is completely different, but it is still solid rocket technology.
Sure.
Right. It's still a 3-stage solid rocket, 4th stage cryogenic vehicle in that regard. So yes, block upgrades is a better way to think of it than that. I mean, another way to think about it too is like, when the shuttle program ended and they took the solid rocket boosters and they stuck another segment on there, block upgrade.
Sure.
Kind of like that.
Okay.
Yeah.
And then chat asking, does the Avon Plus upper stage on Vega C use the RD-843 that's made in that Ukraine factory that just got struck by a missile strike? Yes, that is what we alluded to earlier.
Although they've got plans in place to shift all of that. So,
right, okay.
So we're not expecting a huge actual hit to Vega C and Ariane 6 here from their Ukrainian components.
There you go. And then I should also just mention, to close out the Vega C discussion, this actually isn't this is an interim upgrade to the Vega rocket. There's another variant coming later, right?
There is. Vega will eventually transition to the Vega E rocket as well. So yeah, this sort of interim upgrade gives them a lot more capacity to low Earth orbit and to various medium Earth, low Earth orbit, because the actual orbit they got into, which was about 6,000 kilometers, was the highest Vega had actually achieved. So already demonstrating its increased capability there. But yes, basically the Vega E will provide a cryogenic upper stage that's different from the Avum Plus, and this upper stage will actually replace the solid third stage and the Avum Plus. It'll use methane, so it's going to be a much more optimal cryogenic upper stage that can take advantage of the bang for your buck you get with the solid lower stages, and then do some really interesting upper stage stuff as well.
There we go. All right, I think that recaps the weekend launches as well, and that's going to about do it for this week's episode. Really quick, want to thank a couple more bits of support that have come in here. Jim Cavett with another message saying to the kitty, thank you. Ralph asking, the cat's name is Valentina Tereskova, short Val for short.
Very good.
We can all figure out. I'm sorry, who did this, Michael? Look at the preview. Thank you for that, Michael. I think there's also all right, in like the 30 minutes that she has appeared on stream, there's also a Nightbot
What's her
command
title?
for it now. It's assistant to the news director.
Assistant to the news director,
Fantastic.
yes.
Perfect. And Chris B made the Nightbot command, and it's making fun of Ares. Haygen, I want to thank you for representing Ares 1 in the background today, because it can't just be me up here. Ares 1 fan club needs to represent, all right?
The best rocket ever.
Dudes, I saw the only one of those things launch, and it's the only launch I gasped out of potential fear for when the solid ignited. So,
Oh my god.
yeah.
That is true. All right. We also have one more super chat here from David, who says, Haygen, I enjoyed your and Chris's coverage of the new images and just the joyous excitement you showed in your work. Have a coffee or whatever on me. David, thank you for the kind words. Haygen, thank you so much for all of your James Webb coverage and all of your science coverage. We're glad to have you on NSF Live. Thanks for joining us today.
Of course. Thank you guys for having me. I was so excited to come on here and just geek out with Chris over these images. They're so cool.
Of course. And Chris, thank you for joining us as well, and also geeking over the James Webb images. We're glad. I was like, this week was the easiest job for me, because I was like, well, who wants to be on NSF Live? Obviously it has to be Chris and Haygen. Easy, done. So Chris, thank you for coming on.
My absolute pleasure, man. If you think we geeked out over just talking about the images, wait until we start talking to the PIs and the scientists about the science that's already coming out of these initial images, because that's what we're going to start this week, and I can't wait. Yes.
Awesome. And everyone, thank you for tuning in. I want to give a big thank you, of course, to the YouTube members who send their recurring support to the channel all the time. We really appreciate everything you all do, and you help us do everything that we do. So thank you so much to everyone for their support. And thank you, everyone, for just tuning in or sending super chats or participating within chat. We appreciate all of you. That's going to do it for this week's episode of NASA Spaceflight Live. Stay tuned for future space news coverage. But until then, I'm Thomas Burghardt signing off. We'll see you next time.
Propulsion continues to be normal.
RCP chamber pressure looks good.
Doubling up. Roger roll, Atlantic.
Water towers, fly! Yes!
Tango Delta nominal.
Flight outside SCE off. Say again, SCE off.
Yikes. You bet. Concur. We don't need any more of these.